Welcome to this session. In this session, we discuss how to evaluate determinants using properties of determinants we stated in the previous class. So, what will the questions? So, solution. So, the first problem is to evaluate the determinant 9, 9, 12, 1, 3, minus 4, and then 1, 9, 12. Now, we say that if you add a scalar multiple of a row or column to any row in the determinant or column, the value of the determinant doesn't change. So we are going to say that row 1 to be row 1 plus 3 row 2, and then row 2 to be row 2, and then row 3 to be the same as row 3 plus 3 row 2. So this will give us, so row 1 plus 3 row 2, so 9 plus 3 times 1 is 12. 9 plus 3 times 3 is 18. 12 plus minus 4 times 3 is 0. So that's what you get. And then row 2 is 1, 3, minus 4. And 1 plus 3 times 1 is 3. Is 4, not, so 3 plus 1 is 4, not 3. And then 9 plus 3 times 3 is 18. 12 plus 3 times minus 4 is 0. And so we have this determinant, which is the same as the original determinant, because what you have done is just transform by adding scalars of a row, scalar multiples of a row to another row. Now you see here, this row, you can factor out 6. 6 is common to this, and this element here. So we can say this is the same as factor out 6. And so determinant of 12 will be 2. 18 is 3, 0. Then 1, 3, minus 4. And let's get this one as 4, 18, 0. Because there's a common scalar of 6 there. And also in this third row, we have a common scalar of 2, so you can factor it out. So we'll have 6 times 2, determinant of 2, 3, 0, 1, 3, minus 4. This will be 2, 9, 0. Now this will give you 12, determinant of 2, 3, 0, 1, 3, minus 4, 2, 9, and then 0. Now, because we have now a column with 2 zeros, then that will now make our work easier by compact expansion. we know the sign of this element is plus, minus, plus, minus, plus, minus, plus, minus, plus. So the sign of this element is minus. So the determinant will be 12. So minus 4 will be 4 times the determinant formed by deleting the row and column of this element. So 2, 3, 2, 9. So we'll have 2 by 12 is 48, into 2 by 9 is 18, minus 2 by 3 is 6. So this 48 times 18 minus 6, which is 12. And we multiply by 48, I get 576. And then the second problem is to evaluate without expanding the determinant. So we have determinant of 265, 240, 219, 240, 225, 198, 219, 198, and 181. So the instruction was without expanding below the determinant. So here we are not expected to apply saying now the sign of this is plus, minus, plus, and then we do the compact expansion and expand to get the answer. So we have to use the properties of determinants to do this. So we'll say, let column 1 be the same as column 1 minus column 3. Let column 2 be the same as column 2 minus column 3. And let column 2 remains to be column 2. So this will transform this determinant into, so column 1, this column 1, this column 3. So column 1 minus column 3 means 265 minus 219. That will give me 46. Now 240 minus 198, that will give me 42. 219 minus 181, that will give me 38. Then column 2 remains column 2, so I'll have 240, 225, and then 198. Okay, so column this should have been column 3 remains to be column 3. So sorry for that. Also, I've already specified that column 2 is given by this formula, column 2 minus column 3. So we'll have, so 240 minus 219, that will give me 21. 225 minus 198, that will give me 27. 198 minus 181, that will give me 17. And then this column 3 remains 219, 198, 181. The value of the determinant doesn't change because we have just done adding, we have just done addition of scalar, multiplication of one column to other columns. Now, next step, we say let column 1 be the same as column 2, column 1, and then minus twice column 2, and let column 2 now remains to be column 2, and let's have column 3 to be the same as column 3 minus 10 column 2. So this will transform our determinant into, so we have 46 minus 2 times 21. That will give me 4. And then 42 minus 2 by 27. That will give me minus 12. And then 38 minus 2 times 17. That will give me 4. And then 21, 27, and then 17, because we are not interfering with column 2. And then column 3, 219 minus 10 times column 2, which is 21. I get 9. 198 minus 10 times 27. I get minus 72. And then 181 minus 10 by 17. I get 11. So that's what we have. Now, at this point, remember, we are allowed to play within rows or within columns. So I can say now, next one, I say row 1 to be the same as row 1 minus row 3. And then row 2 to be row 2 plus 3 row 3. And then row 3 to be row 3. So that will be so 4 minus 4 is 0. 21 minus 17 is 4. So this one, this is 21 minus 17. That will give me 4. And then 9 minus 11. That will give me minus 2. And then this will be minus 12 plus 3 times this is 0. And then 27 plus 3 times 17 will give me 78. And then minus 72 plus 33 will give me minus 39. And then this will be 4, and then 17, and then 11. Now, you see this first row has a common factor 2. So I can say 2, determinant of 0. Now this will be 2 minus 1. I keep this other rows. And this one, 39 is common, so I'll have 2 times 39, determinant of 0, 2, minus 1, 0, 2, minus 1, and then 4, 17, and then 11. So 39 times 2 is 78. So I have 78 determinant of 0, 2, minus 1, 0, 2, minus 1, 4, 17, and 11. And this is 0 times 78, which is 0. And the reason as to why this determinant is 0 is because row 1 is equal to row 2. we say that whenever two rows or columns of a determinant are the same, then the value of the determinant is 0. So that's why we conclude that determinant of this matrix, this determinant is 0. So the value of the whole determinant is 0. Thank you.